Thank you for joining me for the second training session on SuperiorBus. My name is Curtis Lyons, and I will be guiding you through our training session today. This presentation has been broken up into short segments so that you can pause, play, or replay it at any time you would like to do so. This training session will explore the technical details of a SuperiorBus and compare a SuperiorBus to other power distribution methods. The first topic we will cover is the advantages of SuperiorBus over wire and conduit, and we will touch on some of the reasons that make a SuperiorBus a more viable system. On the surface, a pipe and wire system may appear to be more cost-effective than a cable bus. However, there are a number of issues that can increase the cost substantially. Unlike a SuperiorBus, a conduit does not allow any airflow to cool the conductors, and the conductors cannot be nested in an efficient phase arrangement. Because of this, the system must be derated in order to prevent the conductors from overheating. As a result, a customer who uses pipe and wire would potentially need to use up to 50% more conductors for the same run as compared to a SuperiorBus. That's a substantial increase in cable cost, especially when using copper cables. The customer would have to pay for a bare ground cable on every single conduit, whereas the SuperiorBus uses the metallic enclosure as a ground and a single bare conductor on the outside of the cable bus for bonding. In order to install a pipe and wire system, the structure first needs to be built, then the entire conduit connected together, and then the cables physically pulled through the conduit. A pipe and wire system is extremely labor-intensive and costly to install. Another issue with pipe and wire is that if a conduit travels from an outdoor environment to an indoor environment, there is no way to ensure a weatherproof seal to stop water from penetrating or running down the conduit. In some industrial installations, like pulp mills and power plants, conduits can be a passageway for gas. Methane gas has been known to enter into conduits and travel down the conduit into switchgears, which may cause an explosion. This is an uncommon occurrence, but it has been known to happen. Conduit has one of the largest footprints for any kind of power feeder system because of the number of tubes required to be placed into a bank. It also generates a much larger installation space inside electrical equipment. For example, if a pipe and wire system is being connected to a switchgear, there will be far more cable terminations on switchgear connections. For example, in a 2000 amp system, there will be a minimum of 600 MCM conductors per phase in a conduit set, whereas in a SuperiorBus, we can cut the conductors down to 3 500 MCM conductors per phase. We are now going to look at the advantages of a SuperiorBus over a cable tray. Unlike any other method of power distribution, a cable tray has no short circuit rating. According to both Canadian and US electrical codes, a power distribution that does not have a short circuit rating cannot be used to connect equipment that have a short circuit rating. To do so, a proper test and analysis would need to be performed to guarantee that the power distribution system has the same rating as the equipment. This becomes a liability for the engineer. In the first training session, we mentioned that the support blocks brace the cables in the event of a short circuit. In a cable tray, the cable is generally secured with zip ties or some kind of wax ring depending on the type of contract and level of contractor experience. During a short circuit, the movement of the cables will likely damage the cable tray and anything else in its vicinity. A cable tray does not have a phase arrangement. Conductors are typically laid out in a row and strapped in, which requires a large system derating. This results in a larger cable tray, more conductors, and more labor to install. Our SuperiorBus package includes all of the components required to put the system together. The sections and fittings are designed and built to fit together based on the measurements or drawings supplied by the customer. Our equipment and wall seals prevent water and dust intrusion into electrical equipment and through building walls. Our fire stop wall seals restore the integrity of a fire-rated wall where the cable bus passes through. When a contractor purchases cable tray, they need to buy a number of individual components and modify them to fit their particular application. The contractor will also have to figure out how to seal the system when passing through walls and into equipment, as well as restore the protection of a fire-rated wall. As a result, the purchase and installation costs of a cable tray are going to be the same or more than purchasing a fully engineered SuperiorBus. The next section is about the flammability rating of the cable bus and components. All of the cables inside our cable bus system are either FT1 or FT4 rated. Cables in a tray inside a building or cables in a cable bus should never be installed without one of these ratings. SuperiorBus uses only FT4 rated cables unless the customer specifically requests an FT1 cable for cost savings. We spend a lot of time educating the customers on cable fire ratings as it makes a big difference in event of a fire. Local laws may require a minimum cable fire rating as flame ratings depend on the National Building Code. The FT1 test is less stringent than FT4. It measures flame spread and flame self-extinguishing over a certain amount of time. This, of course, is all taken into account when we develop a cable bus for a customer. We specify conductors and all materials with these factors in mind. Every component inside our cable bus has been flame tested to make sure that in the event of a fire, a SuperiorBus will not allow the fire to propagate through the cable bus. There are regulations and laws governing fire ratings that are sometimes neglected due to the engineer's or contractor's lack of knowledge. There is a methodology for the location of FT-rated cables. FT1-rated cables can be used in combustible buildings since it does not make a difference whether the cable bus is combustible. Many cables with cross-linked polyethylene, or XLPE insulation, have an FT1 rating because they generally are not able to meet the stricter standards of the FT4 rating. A minimum FT4 rated cable must be used if the building is non-combustible. The fire rating on power cables is generally based on insulation materials. The preferred insulation material for a cable bus cable is ethylene propylene rubber, or EPR, with an outer jacket made from PVC or chlorinated polyethylene, also known as CPE. The outer jacket is typically what determines the fire rating. EPR has many advantages over XLPE. One of the issues with XLPE on all cables is called water treeing. The magnetic field that runs around the conductors during operation in the vicinity of water or a wet jacket can cause the jacket to crack. These cracks, which look like trees in winter, will migrate all the way through the conductor and cause a ground path. This becomes a serious issue when you have high voltage and high ampacity systems, but it is a problem when an XLPE cable is placed outside where it can get wet. This is not an issue with an EPR jacket as they do not experience water treeing. The second issue with XLPE insulation is their resistance to cold temperatures. At low temperatures, an XLPE jacket will become brittle and can crack if stressed. XLPE is not meant for low temperature environments. EPR retains its flexibility at very low temperatures so that there are no detrimental effects on the conductor. This is relevant if a system is being installed in an area that can see ambient temperatures of -30 to -40 degrees Celsius or -22 to -40 degrees Fahrenheit. The preferred cable for low temperature and exterior applications is EPR. However, XLPE cables are the most cost-effective and are most often requested by customers. This is the end of the first part of the second training session.